Hi, my name is John Burks, and this is the third video in a series of videos that I've created. Now, this is the output from the Alteryx workflow created with the render or the report tool. Now, in the previous video, I showed the output of several of the data going to different Excel tabs on in the workbook. And in some of those tabs, we found that the data that was inputted, we were missing the information, and it only gave us the headers, and that's what happens on some of these outputs. And that's why you have to use the render tool or the report tool, which is on the toolbar in Alteryx. And what's great about that particular tool is you can have it downloaded to any location that you want it to be located. Now, what we have in front of us is the Pearson correlation analysis, which is one report that did not output correctly to the Excel spreadsheet, which I was showing you for presentation purposes. And as you can see, we have the Pearson correlation analysis, and Alteryx also allows you to do a Spearman correlation analysis. Now, the difference between the two is that the Pearson is for normal data, normal distributed data, while the Spearman is for non-normal distributed data. Now, you should always do your test for normality to see what type of test you should perform, or else you could end up with the wrong results. Now, as you can see, I'm doing a relationship between two variables, sale price and units sold, and you can see that they are negatively correlated. And it's weakly correlated because it's a 0.068. What we like to see is something around 80 or 90% to say that the two variables are highly correlated, which these are negatively correlated and they have a weak correlation. Now, keep in mind, correlation is not the same as causation. It just lets you know whether or not there's a relationship that exists between two variables. What's also interesting too about this report is it also gives you the corresponding p-values in a matrix. And what this correlation is, this p-value is for, it lets you know whether or not your correlation coefficient is significant, which is letting you know the correlation coefficient is the slope of your variables. And we have here, we got a 0.11015, and if we use the level of significance of 0.05, we would not reject the null hypothesis because the p-value is greater than the level of significance. So this letting us know that the correlation coefficient is not statistically significant, okay, which kind of goes hand in hand with the weak correlation between the correlation or the Pearson correlation, the weak correlation between the units sold and the sale price. Okay. Now, the next report that was outputted is distribution analysis for units sold. And what this does, it gives me gives you your shape. Okay, like I was saying earlier, you should always test your data for normality. So that way the proper statistical test is used. If you don't test for normality, you could end up using the wrong test and come up with the wrong conclusion to your analysis. Okay, and with this particular output, what we have is the skew, which shows which with the skew, which deals with the shape. We have the mean, which is central tendency. We have the median, which is central tendency. We have standard deviation, which deals with your actual spread. So these are key metrics of statistics. You always want to look at your central tendency, which is measured by mean, median, and mode. You want to look at your shape, which is skew and kurtosis. And kurtosis generally is the peak or the pitch of your data, whereas skewness lets you know if the data is more staggered to one side, whether it's left or right. And then, of course, you have standard deviation and you have variation, which lets you know about the spread. of your data. So with here, our skew is 0.44, so it is slightly skewed. The number of total variables that we're looking at is 700. We have a mean of 1,608.29, a median of 1542.50, and a standard deviation of 867.43. And then also what Alteryx does is it does a goodness of fit test, a goodness of fit statistics test, and it has all your p-values over here, and then it does the normal, the log normal, and the Weibull test. So it lets you know how your data is distributed. Okay, and at the very bottom as well, you also have a chi-square of significance as well. Okay. Now the next table is our frequency table. So when you're looking at statistics, you want to, if you have continuous or discrete data, you can do descriptive as well as histograms or box plot to look at your data. But when you're dealing with categorical data, categorical or nominal data, the test that you tend to look at is the frequency tables, and you can also put them in charts. So this is a frequency table on the segment by product, okay? So across the columns, we have the different product types, and then down the rows, we have the channels, and it's giving you the frequency and the percent of the product. And as you go down, it gives you the total frequency and the percent of the different product by the segment. Okay, and these are all should be 100% at the very end, as we can see there. And also what this does is it gives you a chi-square test again, and you have a chi-square of 11.648, your degrees of freedom of 20, and your p-value again is the 0.9277. So your p-value, your probability. Okay. Now lastly, what I did was I generated a regression analysis. Okay. I wanted to see if the segment, if I can model, if I could predict revenues based on the different segments. Okay. So my segment is the independent variable, and my revenues was the dependent variables. And what this does is it gives you for your residuals, it gives you the minimum, the first quartile, the medium, the third quartile, and then the max. But when you look at the actual statistics, what you want to look at is the different p-values. Okay, now the p-value is very low, so this lets me know that there are some items that the model has some values that are good predictors of the revenues. For example, if you look at the significant codes, you have 3-star here, and then you have your segment enterprise with 3 stars, your segment government with 3 stars, your segment mid-market, which is high, okay, and then you have your segment small business, which is a good predictor as well. So what you can do is go back, remodel it, take out the segment mid-market, and you'll have a better model with a predictor of revenues. Now what you also want to look at is your adjusted R-squared. Now this adjusted R-squared is only 0.5436. What this is letting me know is that the model only explains 0.5436 of this variation in the model, which is not too high. I would like to see a higher adjusted R-squared, like maybe 80 or even 90 or 90 and above. So that way I know that I have a better model that can predict my revenues. So if I went, what I would do is go back and maybe take out the mid-market and then rerun the model and then see what my p-values are, see what my adjusted R-squared is, and then see if it is a better predictor of revenues. And then lastly, there's a ANOVA, an analysis of the variance, and it gives you the sum of the squares of the squares of the degrees of freedom, your F value, and then the p-value associated with the F value. And again, you have a significant level, okay? And you have your residuals, which is your actual amount minus the predictors, and then the sum of the squares is taking your residuals and squaring it, and then of course your degrees of freedom is just taking the n and minus 1, okay? And the F value is a different computation. It's looking at, say, your sum of the squares between the variables and the sum of the squares within the model, which is a different mathematical computation. And then down here you have your residuals versus your fitted charts and some other analysis. Okay. Now that was the output using the reporting tool. The reason why I did it this way is, again, is because on some of the outputs you can't really, well, I couldn't export it to Excel because it was giving me the error message, or not error message, but it gives me the header without all the correct information. So when that happens, what you can do is go to the reporting tool, pick the render icon or tool, use that to output your data, and then of course you can output your data to any location that you have on your any path that you would like on your computer. Okay, so that was the reports using the render tool, and then the next video I will go into is Tableau. Now, Tableau is a very powerful and popular software that many companies use. And what I will be doing is taking the workflow that was, I'm sorry, taking the output that was exported from the Alteryx model, input that into the Tableau dashboard, and then create a very general but I think powerful dashboard for people to view. And I'll see you then.